at 13 meters. So this here, this is 13. And then, let's see, the center of mass is located 7 meters, so roughly here. So I'm going to write WC. WC is for the crane. WB is for the blocks. Okay? And what do we start with?
You know the tension, the weight, sum of torques.
Yeah, sum of torques. So always just start with the basics, right? So sum of torques equals 0. Sum of forces equals 0. The sum of torques is fine, right? Let's see. I forgot to label tension. So I'm going to label this just T for tension. And the sum of torques we're going to do soon. Yeah, let's just go in order. So sum of torques. So what is your first torque that we should write?
Over the crane.
Yeah, I personally like to just go along, you know? So this is, actually I should use a different color. So this is RCM. RCM. Right? And then we have this length, which I'm going to call, what do I call this? L. So this is L. And L is here, right? And then we have, I'll call this capital L. And capital L goes all the way from, I'll use another color. Goes all the way from here up to here. So this is L. Okay? So now, sum of torques. Right? First one is just R. Your radial arm. R across, we got to do our rotation, right? So positive rotation, let's just say positive is this way. So positive is this way. A coordinate system, let's have it be X, Y, and then Z. And so we're left with R cross W, RCM cross WC, and it's rotation-wise, we know it's going to eventually be negative, but we'll do that later, plus L, TC, and this one's going to be the opposite, right? So if you go R cross TC, it's the opposite direction, so it'd be the other way. Actually, sorry, R cross this way would be positive. So that's positive, this one would be negative, right? It's the other way. And then we have plus L cross WB, which is this one, right? All the way over here. Okay? So if you look, these things both point down, right? And then this is all in one same direction. So this is phi. I'm going to write this angle over here. So this makes a right degree angle. This is a right angle. Okay. So what is phi? Well, phi has to be equal to pi minus pi over 2 minus 55 degrees. And if we convert that, this is just 180 minus 90 minus 55. So phi is equal to, did I write it anywhere?
35.
Is that 35? Is that right? 35.
Professor, don't we have to use the also the normal force of the elbow of the crane that pushes against the?
No, you always go the angle in between them, right?
Cause like with the arm problem, you said there was like an elbow force E that pointed the other way sometimes.
Oh, yeah. No, you're right. What did I find phi for? No, he's right. Why is it not phi? Can anyone say why?
No.
Remember, it's the angle between them, right? Is phi the angle between that? Yeah, I have it right here, Mark. Yeah, no. This 35 degrees is for finding here. Right, you want to get tension along here, so if this is 35, then that makes this, I believe, 30. Okay? But what is the angle between L and WB?
It's like 65.
Again, remember, like we did, you always just kind of have to draw the vector. So ignore everything, and then your R, your L goes like this, right? And then your W goes like this. So this is the angle, right? So it's this angle. So it's 55 plus 90, or 55 plus 90. So
Did you get the 90 from?
just the fact from here.
Oh, okay.
Yeah. So this is 55, right? And then that's 90. So this becomes. Let me just label this theta. Everyone see that?
Yeah.
So it's the same thing for this one, right? For WC. So they both will have this theta. So it's RCM WC sine theta minus L TC sine, and then the angle between L and TC is this one. It's this angle, right? Because if you look, L points again the same direction as this one, and your weight points this way, right? Or sorry, not your weight, your tension. Your tension points this way. So this is your angle. And we're given 25 here, so this would be, so a line is 180, right? So 180 minus 25, that would be this angle. So let's relabel it actually as something else. Beta. Okay. Beta plus L WB sine theta equals 0. Right? So that's your sum of torques. And from here, all you do is you solve for WB. And when you solve for WB, you should get WB equals RCM W crane sine theta plus LC sine theta divided by, oh wait, this is negative, sorry, minus, and then we subtracted this over, right? So we have to divide by negative L sine theta. And if you plug everything in, you should get that WB is approximately 1.7 times 10 to the 4 newtons. Okay, now,
It still works if the math is still in newtons?
yeah. Well, I asked for weight, right? So what is the maximum weight of the bricks? Weight is newtons. Yep.
For angle theta, is angle theta supposed to be 180 minus 25 degrees of the tension?
It's 180 minus 25. Yeah. This 30 is for our next part, for this. So sum of forces. We have the cord, we have the crane, we have the blocks, and then we have something, right? Because this thing isn't stable. You have two weights pointing down, you have a tension pointing down, there's nothing pointing up. So the thing goes through the floor. You have this tension going to the left, nothing pointing to the right. So this thing goes to the floor and that way, right? So we need something to balance this out, and that's what the next question is. What is the force acting on the axle to keep the crane stable? Right, so let's just call this N, right? And so we plug that in up here. And now let's just look at the components. So X components, you would have NX is equal to minus TC cosine theta, right? Because, did I put theta? So this 30 degrees, let's not call it theta. I already used theta, right? Let's call this
Rho.
rho. Yeah, rho. So this is some rho angle. And that's it. That's the only thing, right? Because there's nothing else. WC is all pointing in Y, so you only have one component there. Right? So, and then for the Y component, you have NY is equal to minus W crane plus W blocks. And that's that. You just plug that in and that's your answer. Okay, for this one, I'm so shocked people were... Did everyone get this? I'm going to erase it soon. Any questions?
It's just after Y, it's the absolute value of the weight of the crane plus the weight of the blocks.
Stop memorizing the form of the equation. Memorize this. The sum of torques is 0. The sum of forces is 0, right? When you're given this problem, you might not have a tension here anymore, right? So what is it going to be? Well, you just set TC to 0, and then do the rest.
Could you use also the sum of forces to calculate the weight? The sum of forces to calculate the weight? Because it gave you
Yeah, you can. It's just the other way around.
Yeah.
Okay, yeah, I'm erasing this now. Well, actually, I'll start over here. Okay, you have a spoke or a flywheel. So this here this is R1, R2, and then you have some spokes. Yeah. Right? And the question is, what is the moment of inertia of the flywheel, assuming the flywheel is a hollow cylinder? Right, so you have a hollow cylinder and these spokes sticking through it. And I gave you the hollow cylinder, so I'm just going to write HC for hollow cylinder is 1/2 M1 R1 squared plus R2 squared. Right, and then this here is M1, and the rods are M2. Some of you didn't include the rods. Whenever there's a mass, you have to include the object. The only way you can ignore the rods is if I said the rods are massless. Then,
And that's what the M1 is, right? M1 is the total mass of everything.
no, M1 is just a cylinder. M2 is the rod. Okay, so what's the moment of inertia? Well, assume we had no rods. What would be the moment of inertia? It would just be that, right? But if we started adding rods, so AC. If we start adding rods, though, it's not actually entirely correct to just add the rods. Technically, you would have to do this. No one did this, but this is the right way you should have done it.
Integral. Oh.
So if you use this on this, just this portion, it should equal 1/12 M2 R1 times 2 squared. Right? This is just a formula for a rod spinning about its center of axis. So if you were to do it this way, you would have to add up 2 of them, or 4 of them, right? So you would have I, HC, sorry, not HC, just I.
Why are we only adding 4?
Because you only have 4.
Spokes.
Yeah, if you take this interpretation. I'm going to do it 2 ways. So this is one interpretation where the rod is this, right? So it's spinning about its center. And there's 4 of them. 1, 2, 3, 4. Right?
Oh, I understood it as there's 8 separate ones.
That's what I'm going to get to.
Oh,
Okay, so there's 4 of them. 1/12 M2 2R1 square plus 1/2 M1 R1 square plus R2 square. If you did it this way, this is the ultimate, this is the correct way. And it's the correct way because this rod at the center acts like it, right? But there's another answer, and this other answer is also correct. And I want to talk about why they're both correct and what's the difference. Okay, so that's one answer. I would say that's the more correct answer because the spokes really do go through, right? If you were to design a tire, a bicycle tire, the spoke goes all the way through, right? So that would be the more correct The other way of looking at it is there's individual spokes, right? So you have 1, 2, 3, 4, 5, 6, 7, 8. So it just becomes 1/3 M2 R2 times 2 square times 4, or sorry, not 4, 8 oh, sorry, this is not 2 either. This is just R2, right? It's just R2 because it's just this length, right? So this is if you have 8 of them, right? And then you just add in the rest, which is 1/2 M1 R1 squared plus R2 squared. That is also correct. If you were to look at them both ways, so if you were to calculate this one, it would approximately be 0.70 kilograms per meter squared. If you were to calculate this one, it is roughly 0.68 kilograms per meter squared.
Wait, brother, so you couldn't just put R2 times 8 instead of doing it 8 times? So like instead of being the whole equation times 8, could it be 1/3 M2 R2 times 8 squared?
I would have to think about it. I don't know.
Okay.
So very similar, right, to the 10th place. If you're around this, it's basically the same answer as that one. Okay, that's that. Second answer. This one, I think people really overthought it. It's not that difficult. I even said the wheel was fixed, so you don't even have to think about momentum, because momentum wouldn't be conserved here. By the way, that will probably be a multiple choice question. Is momentum conserved in this case? And it would be given a word problem. But like, it would be like, you know, why I just, does everyone understand what I just said? Right? Okay. So if the flywheel's fixed, is momentum conserved or not?
Yes.
No, it's not. No, it's not. No, the flywheel, if the flywheel's fixed, momentum is not conserved. Why?
Because of friction?
Well, yeah. Part of that, right? So if the flywheel's fixed and something flies off, let's say one of these things flies off, there's a momentum it takes with it.
Oh.
And when it takes this momentum with it, it needs to change some momentum. It should go this way, but it can't. It's fixed. So it needs to lose energy within the flywheel. And some people did some really clever ways of doing this. But one big mistake I saw is people use the rotational speed. So I say here, flywheel spoke comes loose in some direction with the speed equal to the rotational speed of the center of mass. That is V, right? That is not omega. So if we had an omega associated with this, like omega prime or something, making this thing rotate, this omega prime and this V are completely independent of one another. They do not have any sort of relation. I mean, there's some relation in terms of when it flies off, how it rotates as it flies off, right? But how the problem stated is you can't relate the rotation of this baton to this, because technically it's the speed of the center of mass. It's a speed that acts on the center about which it should rotate. So technically, this induces zero torque, right? Does that make sense? So the baton is flying. You have R cross some force, right? Assuming there's a torque. But this is constant. This is just some constant speed it flew off of. So this is zero. So there's zero torque. You could also say, on the other end, there is a force, but it's acting here. If there's a force acting here, what is my R? If this is the center of mass, what is my R equal to? No. What is R? R is always the radial distance. The radial distance from axis of rotation. Everything rotates around the center of mass. If I am acting on my center of mass, what is my R?
2R.
0, right. So in either case, your velocity should not be something that factors in to omega, okay? It just doesn't, it just wouldn't, it's a good estimation, but it's not very valid. All right, so all I asked was if angular momentum is conserved. So I initial, I final, right? And the reason is because it's rotating, and if it's fixed and nothing can change, the rotational speed should change, right? And that's just a rule of nature. If you want, you can do experiments and try to test it. I highly recommend someone try the experiment where they spin around on like a wheel and they have some weights in their hand and then they draw in and they do that and they spin faster. That rule, when you extend your weights, your arms out and you're spinning and you bring your arms in, that rule is it's valid because of this. And it's because your mass isn't changing. Here, your mass changes, right? And as a result, this rule does not work because mass changed. Does not work because mass changed. Need momentum. And that's the next problem. So you didn't need to do much for this. All you needed to do was I initial, right? Omega initial, I after, omega 1. And the question is, what is the flywheel's angular momentum after? So it's just omega 1 equals I naught, omega naught divided by I after. And if you do this calculation, you're just subtracting one little piece of this. So it doesn't, so if you were just to subtract one of these, it's like 0.69 or something, or 68. I forget.
The other one.
Huh?
Let's use the other one.
It'll be similar. They'll be the same ratio, right? The only difference is that you have to kind of think about it. So if you look here, this gives you 4, right?
Yep.
4, and then this gives you 3, so this gives you 4/3. And if you just divide out and you look at the ratios, their difference isn't that much.
Okay.
But question here. should my frequency increase or decrease just based off this equation?
Decrease.
What was that?
Decrease.
Yes, it should increase. You can kind of think of it like it's giving a kick, right? So after I lose some momentum, or inertia, it gives it a kick. You can kind of think of it like when the rocket is shooting out fuel, it causes the rocket to go faster. This one, you're throwing off some inertia and to make it spin faster.
Interesting.
And the next part, problem 4.
That was problem 3.
This is problem 3. Well, that was problem 3. We're on problem 4 now.
Is there like A and B sections?
No, this is a completely, so you'll see they're different problems. If the flywheel is spinning in space, so it's no longer fixed, it's a different problem. So you have your flywheel spinning in space. A spoke comes loose. You can either do one full rod or you can do partial. It's up to you. I'll just do one for now. So it's initially spinning, omega dot, and then afterwards it loses one of these spokes and it flies off in some direction at some V, and then this goes off in some direction. Let's call this V1, let's call this V2, and then let's call this omega 1, and then omega 2. Okay, and the question is, this will induce momentum change in the flywheel using conservation of momentum. What does the flywheel center mass travel after the spoke flies off? So what is my initial momentum?
10 rats.
No. What's my initial momentum?
1 over 2. 1, 2.
Yeah, 0. So the initial is 0. What is my initial energy? Does anyone know what my initial energy is?
0.
Does anyone know? I'll just leave it as EI until somebody figures it out. And then afterwards, what's my final momentum?
10 meters per second.
V1.
10 meters per second. Turn radians per second, I mean.
No, not an answer. What is it? It's it's whatever the mass of this is, so let's call mass wheel, times B1, plus mass of whatever the rod is, mass of the rod, times B2. Okay? So this is a final. And then what is my final energy?
Isn't it the same as initial energy?
Right, there's some kinetic energy. What else is there?
Isn't it the same as the initial energy? Because of conservation.
Well, yeah, but what is it total in terms of your variables, right? So we have, you said kinetic, right?
Minus the kinetic energy of the spool when it flies off.
you're jumping to the end. I just want, so this is 1/2 m rod v2 squared plus 1/2 m wheel. I'm gonna say wheel prime because it's after, it changed, right? So wheel prime would be v1 squared plus, you need the rotational kinetic energy as well. So this is 1/2 I after, I'm just gonna put IF for final, IF, omega 1 squared plus 1/2 I rod, center of mass, omega 2 squared, right? Did anyone figure out what this should be? Not value-wise, just algebraically. Is there any initial kinetic energy?
No.
What kind?
Rotational.
Yeah, that's the only thing. Okay, and this is really all what you need to solve this. First, you need to solve for what did I give you here? So we know V2. Does anyone know what V2 is? A lot of people got this wrong. They said R2, or sorry, R1. They did R1 times omega naught, right? That's wrong. R1 is here, right? I said the center of mass, right? So it's here. So there should be a 1/2 here. Okay, so that's V2. So that means V1, this has to equal P initial, which is equal to 0. Solving for V1, we get V1 has to equal m rod divided by m wheel prime, right? Prime, it's after V2 minus. Here, this is just magnitude, right? I have to pick a direction. I'm just going to call this direction n vector. So to make this a vector. All right. And in fact, n can just be a unit vector. So it just tells you the direction. Whenever you don't know a direction, you can just declare a unit vector in that direction. But keep in mind, all operations that you do afterwards have to keep in mind the angles with respect to that direction. Okay, so if we set these two equal, we use these two, we plug them in here, and we solve, we should get omega 1 squared equals I wheel omega naught square minus m final, or wheel prime, v1 square minus m rod v2 square minus I rod omega 2 square, all divided by I after. And if you plug everything in, you should get omega 1 equals 9.79 radians per second. So in this case, right, because you can't just magically get energy from it spinning and being fixed, you actually reduce your speed. Whereas in the case where things get violated, you actually increase your speed. So by imposing conservation of energy, you get things that make more sense. Okay. Was that all of it? I don't need to do the pendulum, do I?
No.
Algebraically. Why are people afraid of that word? Algebraically. Algebraically is the easiest. Easy. I'm not asking you to solve anything. What does algebraically mean? Algebraically means you label your picture with labels that you like, that you want. So this is D. This is L. This is M1, M2. I asked for the moment of inertia. Okay, if we were going to sum up along this arm, what's the first thing that we would have to have here? It would just be, like before, I rod. Here it's the end. Right? End rod, so the rod rotating about the end, this point P here. Here's your center mass, sorry, I didn't write this. So this is the rod. This is the point mass. And then you add up high point. But this isn't algebraic yet, right? You could say that this is algebraic, but it's not complete yet because you still have to incorporate your labels. M2, D, M1, L, right? So what are these in terms of those? It's 1/2 M1 L squared plus M2 L plus D squared. Is this the final answer? Yes. Okay, that's it. Algebraic, right? Yeah, sorry. It's 1 through. So that's it, right? But you gotta explain your steps, right? You gotta have step here, step here, step here. If you just write this down, I'll give you partial points, but I won't give you all of them. But there should be reasoning. All the words that I spoke, they should be written. They should be written on the page, you know. So that was first part. Now part A, center mass. Again, algebraic. Start with that. Start with the basic. Don't do anything fancy. Don't try to skip steps. Just write out the basic stuff. Okay. As your professor, when I do problems at home, on my own problems, right? I always draw a picture and I always start with the basic definitions and I always go from there. If I always have to do that every time I do a problem, and I'm not working on fancy problems, I'm working on very simple stuff. If I have to do that, then, and you're not doing that, then you should become a physicist, okay? Because you're doing things far better than me. All right, so M1, right, its center mass is L over 2 distance, so that's your R1. So if we were to just write this out as M1 R1 squared plus M2 R2 squared, M1 plus M2, we can then say R1 is equal to L over 2, and R2 is equal to L plus D. Therefore, so this is a little symbol. So if you ever see someone do those 3 little dots, that means therefore. So therefore, sorry, this is arrows, is M1 L over 2 R hat plus M2 L plus D R hat, all divided by M1 plus M2. And then you can just factor out your R1, so you have M1 L over 2 plus M2 L plus B divided by M1 plus M2. Alright. And that's your final answer. That's algebraic, right? That's it. If you didn't have an R hat vector or some vector, I didn't give you full credit for that.
Damn.
Okay. This one is actually pretty straightforward if you're okay with algebra. There was no solving. There was no quadratic equations. It was just algebra. The thing is, what must M2 be for the period to be 2 seconds? Okay, so we have T equals 2 pi I M total RCM G. That's just the definition. I gave it to you. And then all you do is you take these expressions we derived here and here, and you just plug them in. And then we want this to be equal to 2. Right, so we have 2 equals 2 pi. One third M1 L squared plus M2 L plus D squared, all divided by M1 plus M2 times 1/2 M1L plus M2 L plus D divided by M1 plus M2 times G. Right? So if you just look here, this cancels with this, right? So, and then I'm going to move this over here. So we have 1 over pi equals square root 1/3 M1 L squared plus M2 L plus B squared, all divided by 1/2 M1 L plus M2 L plus B. If you try to plug things in and do it any other way, it gets really messy really fast. I highly recommend try to keep things grouped. Things that show up multiple times, like M1 plus M2, you can always just call it some capital M total. Right? I hope all of you, by the end of this course, really are solid with algebra. But unfortunately, in a math class, so I ain't gonna test you on that. So 1/3 M1 L squared plus M2 L plus B squared, all divided by 1/2 M1 L plus M2 L plus B. So for those of you good at algebra, what should I do next here?
You could take out. You could take out.
Was that multiplied by what? No. I would multiply by my denominator. So I have 1/2 M1 L plus M2 L plus D. But if I multiply by my denominator, I have to do it over here too. So I have 1/2 M1 L plus M2 L plus D. Always, from your, I don't know how math is taught in Florida, but always get rid of your denominator first. Whenever you have it, just get rid of it.
Professor, what happened to the gravity in that?
Oh, sorry, G is here still. All right, and in fact, I'll multiply by G as well here. So G, G, and if you do that, you should get G over pi squared times 1/2 M1L plus M2L plus D is equal to 1/3 M1L squared plus M2L plus D. And then here you can see it's linear in M2. See that? A linear M2, linear M2. So if you group and you solve, you have M2 is equal to 1/3 M1L squared minus G over 2 pi squared M1L, all divided by G over pi squared L plus D minus L plus D squared. That's the answer. So if I ask for what is the algebraic expression of M2, you're done. This is the algebraic expression for M2. And if you plug everything in, it's roughly 1.36 kilograms. Okay. What time is it? I don't know if I should go on. I think it's good. Any questions?
The time extension, retake exam 3 is extended to next week, correct?
Yeah, you can take exam 3 up till next Friday, only exam 3, because I haven't finished grading it. So deadline for retakes of exam 3 is next Friday, but deadlines for any other exams is this week. So 11 a.m., Tuesday, Thursday, Friday. If there's too many people, I'll have to turn some of you away. So try to be there if you can, if you need to do retake. So far, I will not have a lot of people doing retakes tomorrow. So if you can come tomorrow, try. There's only like 1 or 2 people coming tomorrow. Yeah. Okay, that's it.
Next week is the same Tuesday, Thursday,
We just
Friday.
went over the exam questions.
Next week?
Yeah.
Yeah. Thank you.